So this is called From Core to Float. Now, what is that about? The future of Queensland is at stake. The future of Queensland's critical mineral development rests, to a large degree, on a reliable and economic source of and supply of sulfuric acid. Multiple studies have identified pyrite as a very promising source or raw material for sulfuric acid production. Now, this means that the substance that is currently a major cause of acid mine drainage could instead become a critically valuable commodity to enable the production of resources for building decarbonisation infrastructure. But pyrite is complicated. It occurs in a variety of mineralizations, in mineral textures and compositions. And so to effectively make use of this valuable resource, we need to have more holistic models and approaches to design treatments for its extraction. Thus, we need not only data, but ways to gather information to enable us to design these processes. Otherwise, we'll end up data-rich, but insight-poor. So the technique I'm presenting today is a new approach to effective data reduction and information enrichment. And the goal is to support better decision-making about pyrite recovery via flotation with a view to increasing sulfuric acid production. So we started with a geometallurgical dataset related to pyrite, which included variable measurements from ore domains, from the core samples, mineralogy, pyrite flotation recoveries, pyrite textures, and electrochemistry results. So that was 85 variables in all. And although I'm not a statistician, I have it on good authority that after choosing a suitable p-value cutoff, which we formed a cross-correlation matrix from these 85 variables, and that's important for later, so just hold on. And from that, identified 225 correlations of significance between pairs of variables. Okay, so variable pairs that had significant p-values between them. This gave us 85 variables that were significantly related in some way to pyrite flotation. But to understand more specifically where the key variables are, or what the key variables were out of that set that directly influence pyrite recovery from flotation, we turned to graph theory. And this is the cool bit. If you're waiting for it, this is the cool bit here. A cross-correlation matrix between variables is mathematically identical to an adjacency matrix that represents an undirected graph, as you see in the picture. So we visualize these 85 variables and their significant correlations as the variables as nodes in the graph, with the edges between pairs of nodes drawn in if there was a significant correlation identified from that cross-correlation matrix after you apply the p-value cutoff. And so this network here, or is part of the visualization of that cross-correlation matrix. Now I'll just highlight a particular area in the graph, just this little bit here. I wanted to highlight that from the graph, we could identify which variables out of this network of correlations, which variables were directly connected to the two pyrite recovery variables of interest. This gave us a set of 14 variables out of that 85 that had the most direct correlation with pyrite recovery. Now, the point of this is that although these are interim results, identifying these 14 variables helps to plan future experiments to optimize pyrite flotation, opening up new possibilities for sustainably sourcing sulfuric acid. Now, this was not done all by me, of course. I'm not a geologist nor a minerals processing person, but this was the full team, some of whom are in the room. If you have questions about some of the experiments or some of the stats applied, please talk to them. I'm just the graph theory guy. Thanks very much.